Welcome to the Three Takeaways podcast, which features short, memorable conversations with the world's best thinkers, business leaders, writers, politicians, scientists, and other newsmakers. Each episode ends with the three key takeaways that person has learned over their lives and their careers. And now your host and board member of schools at Harvard, Princeton, and Columbia, Lynn Thoman.
Hi, everyone. It's Lynn Thoman. Welcome to Three Takeaways. Avi Loeb is our guest today. He is an Israeli-American astrophysicist who is chair of Harvard's Department of Astronomy. He's published hundreds of scholarly papers as well as 6 books. He's also made a growing number of now confirmed predictions touching on the birth of stars, the detection of planets beyond our solar system, and the properties of black holes. He is one of the most respected astronomers in the world. I'm excited to find out why Avi believes that we are not alone and that there is intelligent life beyond Earth. Avi, thanks so much for being here today.
Thank you for having me.
Avi, why do you think we may not be the smartest civilization out there?
Well, the reason is simple. If you open a recipe book, you immediately realize that out of the same ingredients, you can make very different cakes, depending on how you mix the ingredients, at what sequence, and also how much heat you apply, and so forth. And the same must be true for how you mix chemicals on a planet like the early Earth. We think that we originated from the soup of chemicals that existed on Earth. That's how life started. And then we are the more complex forms of life that emerged on Earth. But there is no guarantee that we are the best cake that one can imagine out of this soup of chemicals. And if you have billions of other planets in the Milky Way galaxy where the ingredients were the same, but the way that the cake was cooked was different, then it's quite likely that some of these cakes turned out to be much more tasty, that some of these creatures out there are much more intelligent than we are. I don't pretend to believe that we are the pinnacle of creation in any way. By looking at the morning newspaper, that's one evidence that we are probably not.
How do you think about exploring space?
I think space is fascinating because it's the ultimate frontier. We never know what we might find. When Columbus went out into the ocean, he did not expect what he actually found. And obviously that was just on Earth, and it was a new continent. And then there were people living there, and eventually, we now live in the Americas that were discovered. And I think going into space would be a similar experience. We are going into an uncharted territory. We don't know what we might expect. Anyone that says that he or she knows are just like those that thought that there is no point in leaving Europe because we pretty much know the map of the world. And so the exploration of space is basically going out of our backyard into the cosmic street and seeing what's out there. There are plenty of opportunities. Well, first of all, opportunities for human civilization to not be so vulnerable just on one planet. There are opportunities for commercial opportunities because, for example, there are elements that are extremely precious on Earth. They're worth a lot of money, and they might be abundant in asteroids, and you can mine asteroids. But also, we might find evidence for life out there, and it will change our perspective about our place in the universe, our aspiration. If you imagine that there is life like us elsewhere, it could change the way the religious beliefs of many people. A lot of these beliefs are rooted in us playing a central role in the universe, that everything is focused on us. But if there is something out there, then it changes your perspective. And I think it's just expanding your mind to figure out how we came to exist, what is out there. And speaking about how we came to exist, the ultimate question is, where did we come from? Did we just form out of a soup of chemicals on the surface of Earth? Or do we have an ancestry that extends beyond the Earth? Perhaps the seeds for our existence came from somewhere else. And then in the bigger scheme of things, we know that the universe started from a Big Bang, but we don't know what happened before the Big Bang. It's an interesting question. It's possible that the universe was created in the laboratory of some other species. And we don't have a theory right now that unifies quantum mechanics and gravity that can tell us what happened before the Big Bang. It's possible that once we develop that theory, we will figure out that it's possible to make a universe like ours in the lab. You can just irritate the vacuum enough and create a universe like that. So that would mean that perhaps our universe started, our umbilical cord goes to a laboratory somewhere else. There are fascinating questions about where we came from that bothered people throughout history, for millennia. If you look at all the religions that are trying to address this question of where did we come from, what else is out there, what's the big scheme of things, we want to figure it out. And the way to do it with modern science is by collecting evidence, by exploring space.
How many habitable planets do you think are out there?
Well, we now know from the Kepler satellite that about half of all the sun-like stars have an Earth-sized planet in the habitable zone around the star. We thought that we are really special, but in fact, the Earth-Sun system is very common. There are billions of such systems in the Milky Way galaxy alone. And then there are tens of billions of Milky Way-like galaxies in the observable volume of the universe. So altogether, there are more Earth-like planets with conditions similar to the Earth in the observable volume of the universe than there are grains of sand on all beaches on Earth. Now, what does it teach us? Well, two things. First, that we should be modest. All the kings and emperors that conquered a piece of land on Earth resemble an ant that hugs a tiny grain of sand on the landscape of a huge beach. It's nothing to be proud of, even if you conquer half of the world. It's nothing. It's compared to the landscape of the universe. So first of all, we should be modest in whatever we do, because we are so tiny relative to the universe. But more importantly, the dice was rolled so many times, billions of times in the Milky Way, and then tens of billions of times in the universe. Most likely, we are not special. We are not the only ones. We are very common, just like ants on a sidewalk.
Can you elaborate a bit why you think there is life out beyond Earth?
Well, we know that there is life on Earth, and it started relatively early. Intelligent life started late. And I would just argue that if you arrange for similar conditions on so many planets out there, the outcome would be similar. This is just a conservative point of view. It says if you take a system and replicate it, you get the same outcome. To me, that sounds very conservative and should be the mainstream of astronomy. But unfortunately, my colleagues, scientists, the people that practice astronomy, regard it as a speculative notion that there is life out there and that, in fact, there is intelligent life out there, or that we should search for it. Now, of course, if we bury our head in the sand and don't look for it, we will not find it. If you don't search for wonderful things, you will never discover them. My point is, irrespective of what barriers we put, what limits we put on our exploration, it may still be out there. If you look at the experience of Galileo, he argued that the Earth moves around the sun. And then philosophers at the time said, oh, that's unreasonable. We know that the sun moves around the Earth because we are at the center of the universe. And they refused to look through his telescope. And they put him in house arrest because what he said was not acceptable to them. So what? That didn't change the fact that the Earth moves around the sun. So if we put blinders, it doesn't change reality. It just keeps us ignorant for a longer period. And of course, people can be happy being ignorant by blocking their view, by saying, let's not even check if we are wrong. But that's not the way science should be done. Science is all about being open-minded, looking at the evidence.
Going back to the evidence, how do you explain the paradox that given the vastness of the universe, the probability of extraterrestrial life as you see it seems very high, and yet we see no evidence of it?
There are several possible explanations. One, that technological civilizations are not very smart. They behave just like us. If you open the morning newspaper, we're trying to fight each other, going to wars, going to disputes. That makes no sense. We are wasting a lot of time and energy on things that are not productive. We are destroying the climate. We don't care about our future as much as we should. And it doesn't show great level of intelligence. And you can imagine that a technological civilization like ours would survive several centuries and then develop the means for its own destruction. And if that's the case, that explains why we don't see many of them alive right now. Most of them are dead by now. That doesn't mean that we cannot find evidence for those civilizations that died, because in archaeology, we dig into the ground and we find evidence for ancient civilizations that existed before us. We can still find artifacts that they left behind. And the same is true for space archaeology. We can dig into space and find evidence for burnt up surfaces of planets or atmospheres of planets that were polluted by too much so that the climate changed. We can find evidence for those things. That will educate us that there are lots of dead civilizations out there. Another possible solution for why we don't see them is that perhaps those that are long-lived are the ones that develop technologies that are much better than ours, because our technologies evolve on a few-year timescale exponentially. And so imagine what would happen in 100 years, 1,000 years, 1,000,000 years, or 1,000,000,000 years. We would reach a level of sophistication that we cannot comprehend right now. And a civilization that is so sophisticated might develop its own habitat and close itself off, basically build a cocoon around itself, inside of which they enjoy everything they need. They don't need to interact with anyone. Of course, not with us. We are much less capable. So then it doesn't mean that we wouldn't find that they exist, because the second law of thermodynamics says that if they use energy, they must produce trash. And just like investigative journalists that go to the trash cans of celebrities in Hollywood to find out what happens in their private lives, we could potentially find evidence for the trash that they throw and learn about what they do inside their cocoons. But that would explain why we haven't been approached. We are such a low-level intelligence that we are not of interest, and, they just ignore us.
Could other civilizations have started billions of years before us and be considerably more advanced or completely different from us? Are we likely to be the best or the most advanced species?
My sense is that we are probably common, that we are not necessarily the most advanced. If you look at the sun formed at the tail end of the star formation history of the universe. So there are many more sun-like stars that formed earlier than the sun by billions of years. And if you just imagine the same history around those stars that formed much earlier, and you imagine those civilizations preceding us by billions of years and surviving, being smart enough to avoid catastrophes, for us it would look like magic if we ever meet their technologies. I would guess that most of those that preceded us are by now much more sophisticated than we are. We have technologies, modern technologies, only for about a century, and we are just at the beginning of our development, technological development. So if I had to guess, I would say that we are common, that things like us exist out there. Perhaps many of those died because they didn't behave smartly enough, but that there are much more sophisticated species out there. And the only way to find out is by searching, by looking for evidence and exploring the sky with an open mind and not closing off.
Avi, I just finished reading your new book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. It is terrific. Can you tell us about that?
So this book focuses on Oumuamua, which is the first interstellar object that was discovered in the vicinity of the Earth that came from outside the solar system. It moved so fast that it couldn't be bound to the sun. So it's the first time we saw an object, and a real object that came from outside the solar system. It was discovered on the 19th of October, 2017, on its way out of the solar system. At first, people said, it must be a comet or an asteroid, just like the objects we have seen before, from within the solar system. But then as the data was collected by astronomers, it started looking very weird. There were many anomalies associated with Oumuamua. For example, its brightness changed by a factor of 10. So that means that the area of the object on the sky was changing by a factor of 10 as it was tumbling around every 8 hours. Even if you take a single sheet of paper, a razor thin sheet of paper, and let it tumble in the wind, the area that projects onto you is not changing by more than a factor of 10 typically, because you never see it exactly edge on. So that meant that the object must be a very extreme geometry. And then there was an extra push on the object that could not be accounted for. Such a push beyond the force of gravity that comes from the sun, we suggested that it may be a light sail in a scientific paper, and basically a sail that is pushed by reflecting sunlight, which is a technology that we currently develop here on Earth for space exploration, where you take a very thin layer of material and propel it by bouncing light off it. It's just like the sail on a sailboat that is reflecting the wind and gets a push as a result. And a couple of years later, there was another object found, but this one was bound to the sun. This one also didn't show a cometary tail, and it also exhibited some extra push from sunlight. And then astronomers integrated the orbit back in time and found that in 1966, it intercepted with the orbit of the Earth. Then they went to the history books and realized that in 1966, there was a lunar lander, Surveyor 2, that was launched and the mission failed. And the rocket booster from that mission went into an orbit. And so this was a relatively hollow structure that had a large surface to weight ratio. And so that's why it was pushed by sunlight. So this is a demonstration of this idea that we can identify artificial objects by the fact that they don't have a cometary tail, and yet they are pushed by sunlight. And this one is artificial, made by us. It's a rocket booster from a 1966 mission. But Oumuamua clearly is not bound to the sun, and therefore it came from outside the solar system. It exhibited similar features. And if it's artificial, it implies that it's a message in a bottle. It implies that it may have come from another civilization. I should say, I enjoy, when going on vacation, to walk on a beach and look at seashells that were swept ashore. These seashells are different from each other and they are naturally produced. But every now and then I encounter a plastic bottle, which implies that it was artificially produced. So it's possible that Oumuamua is a plastic bottle. And most of the time we see these rocks that are naturally produced objects. But every now and then we might see an artificial object like Oumuamua. I think the way to make progress is by exploring anomalies rather than shying away from them. That's where you will find things that you haven't expected. So if you see something that doesn't quite line up with things that you have seen before, that's the place where you have to focus your attention rather than the other way around. For example, quantum mechanics was really very strange to most physicists at the time. And Einstein resisted, as I mentioned, the notion that you cannot predict exactly what might happen and that it's completely different from what we think in terms of classical physics. Nevertheless, it agreed with all the experiments, and we now know that it is very weird. So the process of science gaining knowledge is based on paying attention to anomalies. Astronomy teaches us to be modest. We should never think very highly of ourselves. If you start from this point of view, then you are basically a student of nature. You're trying to learn. Let the universe teach us. Let's collect evidence, figure out what things are like. That's the approach of a child. We are all children. Anyone that pretends to be an adult that knows everything is lying. We don't know everything. We know very little. The knowledge that we have is just an island in an ocean of ignorance.
So, Avi, you essentially believe that it's arrogant of us to believe that there is no life beyond Earth. And I love your analogy of the caveman. Can you tell us about that?
If you imagine a caveman finding a cell phone, a caveman is used to seeing rocks and playing with rocks. And then when the caveman sees a cell phone, he would think that it's just a shiny rock. And that would be the natural interpretation. And the caveman could even write a review paper in Nature magazine saying, must be a rock. That's it. And that's what the astronomy community, a group of people came together from the mainstream saying, Oumuamua is natural, period. End of discussion. And then, of course, people that are not professionals would say, oh, well, there are experts, quote unquote, saying that it's natural, therefore it's natural. But then within the mainstream of astronomy, there were a few people that paid attention to the anomalies and tried to explain them. That's unfortunate because I think we should focus on anomalies. And if they look unusual, the reason it's important is because when the next object shows up and we should search for it, then we should use our best equipment, our best telescopes, perhaps design a space mission to meet it halfway if we see it coming our way, and then take a photograph and get more evidence. I'm advocating for getting more evidence. Those people that say it's always natural are saying, let's not even check because it's always natural. Of course, that's one way of not finding anything unusual if you don't check.
Before I ask you for your 3 takeaways, is there anything else you'd like to discuss that you haven't already touched upon?
Oh, one more thing, yes. In a Scientific American article that I wrote, I made the analogy between the situation that we have in preserving everything we care about on Earth by going into space to the situation that Noah in the biblical story had when confronted with a great flood that is about to come. And Noah built an ark. The legend is that he put animals in the ark to preserve them from the great flood. You may say, okay, well, maybe we should do the same thing and launch into space something that we would call Noah's spaceship that will preserve everything we hold precious here on Earth. At first, you might think, oh, we need to put elephants, whales, birds on that spaceship. But that's not true because with modern science, we know that all the information about these animals is encoded in the DNA. So all you need is to have a computer system that stores the information of the DNA of those animals. And then if we learn how to make synthetic life, all you need is a 3D printer on that spaceship that can reproduce the life that we have here on Earth on the surface of another planet out of the raw materials that are there. You can have a CubeSat, a very small satellite that weighs 1 kilogram, that doesn't carry any animal or any human being, but carries the information about how to make the recipe or a cookbook, you can think of it, for making the type of cakes that you care about, the life that we have here on Earth on another planet. And you send this spaceship to space and it goes to other planets where life is possible. And so that would be a way of spreading our eggs and not keeping them in one basket so that we at least have some peace of mind. If we don't behave properly on Earth, it doesn't mean that everything we care about will be annihilated.
Avi, what are the 3 key takeaways that you'd like to leave the audience with today?
The first takeaway is that the universe teaches us modesty. We should be humble because we are so small relative to everything that we see out there. And I emphasize the word see. We observe, we have evidence that there are many Earth-like planets around sun-like stars in the observable volume of the universe. And so the vastness of that system, that environment that we live in, and the fact that our system is not very special should teach us modesty. We are sort of not at the center of things, and we are probably very common. Okay, so that's takeaway number 1. Takeaway number 2, we are not likely to be the sharpest cookie in the jar because our technologies are only a century old. It's quite likely that there are civilizations that had more time to develop their technologies. And therefore, we should try and learn from them by collecting evidence for their existence. And finally, takeaway number 3 is that we should appreciate the fact that we are all students of nature. We are of Mother Nature. We are trying to learn what Mother Nature teaches us. And as such, we should be open-minded, behave more like kids than pretend that we know everything and try to get honors and appreciation from other people. The truth has nothing to do with how many likes you get on Twitter. That's an extremely important takeaway. don't pay attention to what other people think. You should think yourself critically based on the evidence, on what you know. It's the same takeaway that the basketball coaches give to their teams. A good basketball coach says to the players, keep your eyes on the ball, not on the audience. And so that is my takeaway about science. We should keep our eyes on the evidence. The ball is the evidence, rather than look at each other and try to get respect from each other. That's not the key to understanding nature.
Avi, this has been terrific. Thank you so much for your work, for all your findings on space, and for your book, which is terrific.
Thank you for inviting me.
If you enjoyed today's episode, you can listen or subscribe for free on Apple Podcasts or wherever you listen. If you would like to receive information on upcoming episodes, be sure to sign up for our newsletter at 3takeaways.com or follow us on Twitter, Instagram, Facebook, and LinkedIn. Note that 3takeaways.com is with the number 3. 3 is not spelled out. For all social media and podcast links, go to 3takeaways.com.